Ever heard of a math problem that kept scholars guessing for over 2,000 years?
Oh, yeah, definitely.
Get ready to dive into Archimedes' cattle problem,
That's a good one.
a brain teaser that's part ancient history, part serious math.
And all parts
You
intriguing.
got that right, so no pressure on us to solve it then. But seriously, we're talking about Archimedes, the guy who practically invented physics in the bathtub.
Right, right.
Did he just think up this cattle conundrum as like a fun side project?
Well, it's even more intriguing than that.
Yeah.
Imagine it's 1773, and someone stumbles upon this ancient manuscript.
Okay.
Not just any manuscript, it contains a hidden poem, and tucked away within that poem is Archimedes' problem.
Whoa.
Talk about a long-lost treasure.
Hiding math within poetry, that's a next level cryptic. I mean, was this a common thing back then? Did poets double as math tutors?
It certainly speaks to a different way of thinking about and sharing knowledge. It makes you wonder what other mathematical secrets might be hidden within ancient texts.
Okay, I'm hooked. Let's talk cattle. What's the deal with this problem?
Picture ancient Greece. You've got a herd of cattle belonging to Helios, the sun god. But we're not talking about your average farm animals.
Of course not. It's the sun god. Gotta be something epic.
Exactly. Imagine cattle in 4 colors: white, black, dappled, and yellow. And to make it even more challenging, there are specific ratios for the bulls and cows of each color.
Okay, getting a bit more complex than your average head count. I can see why they needed Archimedes on the case. So what's the actual problem? Do we just need to figure out the total number of cattle?
You might think so, but it gets a lot more interesting. The false part throws you a curveball. A system of 7 equations with 8 unknowns. Now, here's the kicker. The smallest possible solution involves a herd of over 50 million cattle.
Wait, 50 million? That's more cows than I've ever dreamed of. Did Archimedes have a thing for big numbers?
He certainly did. And that 50 million, it's just the smallest possible solution. There are infinitely many others, each a multiple of the first.
Infinite solutions. My brain's already doing backflips, but wait, there's more. Archimedes was just getting started, wasn't he? Tell me, how do you make a problem about uncountable cattle even more challenging?
He did not stop there. Let's just say Archimedes didn't stop at just astronomical numbers.
There's more?
Oh yeah, he layered on a geometric puzzle just to keep things interesting.
Geometry. Now we're adding shapes to the mix.
It's a doozy.
I'm starting to see why this problem took centuries to solve.
This is where it gets really elegant. Remember those white and black bulls? Archimedes stipulated that they must be arranged in a way that forms a perfect square.
Okay, like a massive checkerboard, but with bulls instead of checkers. I can picture it.
Exactly. But hold on, because he wasn't done. The yellow and dappled bulls had to be arranged to form a triangular number.
Triangular number. You're going to have to explain that one.
Okay, so imagine arranging objects,
Right.
where each row has one more than the last. That's a triangular number. 1, then 1 plus 2, then 1 plus 2 plus 3, and so on.
Okay, I get it. So it's not just about finding huge numbers of cattle anymore. It has to be specific numbers that fit both the original ratios A and D, these geometric patterns. Talk about a brain teaser. It's like Archimedes was inventing a whole new type of math cattle geometry.
He essentially was. And it took a while for anyone to even come close to a full solution. Fast forward to 1880 when Carl Ernst August Amthor used logarithmic tables, cutting-edge tech for the time, to find a general solution.
General solution, does that mean we're getting close to a concrete answer?
Well, sort of. Amthor figured out a way to represent all the possible solutions with a formula, but the numbers were still mind-bogglingly large.
Yep.
The smallest solution had a whopping 206,545 digits.
Okay, that's a lot of digits. Did they ever figure out the full number? Did anyone try to write it out?
Believe it or not, there was a group up for the challenge. In the late 1800s, the Hillsborough Mathematical Club in Illinois managed to calculate the first 31 digits and the last 12. But the middle part. That remained a mystery for quite a while. Imagine being so close yet so far. It seemed like a complete solution was just impossible.
It's like they climbed Mount Everest and only made it to the base camp. So how on earth did they ever crack the rest of it? Don't tell me computers into the picture. You're telling me a problem that stumped generations of mathematicians was ultimately solved thanks to a computer. I guess the future really does wait for no one.
It's a classic example of how technology can completely change the game. In 1965, a team at the University of Waterloo used an IBM 7040 computer to tackle the problem. Took the computer a good 8 hours to crunch all those numbers.
8 hours? I mean, I've waited longer for my laptop to update, but considering the problem stumped people for centuries, that feels like record time.
Definitely. And all that computing power resulted in a 47-page printout of the complete solution.
Isn't imagine.
Rows upon rows of digits. It's almost comical to picture.
Talk about a long receipt. But I bet the story doesn't end there. Technology keeps advancing, right?
Right you are. Fast forward to the 1980s, Harry Nelson at the Lawrence Livermore National Laboratory took on the challenge with a Cray 1 supercomputer. This was one of the most powerful machines at the time. How long do you think it took the Cray to find the solution?
Okay, we're talking supercomputer here. Seconds.
10 seconds flat. The cattle problem had officially met its match.
Wow, talk about a knockout punch. It makes you wonder what Archimedes would have thought about all of this. I bet he'd be itching to get his hands on a supercomputer.
I think so too. But beyond the technology, it's really a testament to human curiosity. Even after a solution was found, mathematicians kept exploring the cattle problem.
So it wasn't just about getting to that final answer. There was more to uncover.
Absolutely.
Yeah.
In 1998, a mathematician named Elon Vardy found a way to simplify the formulas needed to solve it. And then Anna Nygren developed an algorithm that could find the smallest solution using a regular computer in mere seconds.
So we went from needing a room-sized supercomputer to something you could practically do on your phone. That's incredible.
It really highlights how intertwined math and technology are. They push each other forward in ways we couldn't imagine.
This whole deep dive has been mind-blowing. It's amazing to think that something as simple as a herd of cattle led to such complex math and technological advancements. It really makes you appreciate the power of curiosity and the elegance of math, even when it's hidden behind a herd of millions of cattle.
It goes to show that sometimes the most intriguing puzzles are the ones that seem impossible at first glance. Who knows what other mathematical mysteries are waiting to be unraveled?
Maybe we'll tackle another one on our next deep dive. Until then, keep those brains buzzing.